Hello, grade 12 once more. Now let's look at March 2014 question 2 paper 1 transition piece. For March, the front view and the top view of a square to a round. This one now is from a square into a round. It's changed from being a square. As it goes up, it becomes a round piece. Square to a round transition piece. Draw to scale 1 to 1 the following. The given front and top, and then you develop the transition piece. In this case, you have been given a seam where it has been cut. It comes from the March 2014 paper. Now let's redraw. Let's redraw that. And as I redraw, I like to redraw as far as possible to the left. As possible to the left, so that I leave enough space for my development. It is a square 60. I also like to indicate my center, and there I draw them as usual, both views. It is a 60 by 60 transition piece. Also there is, and then we go up, we have a center. Center line, remember, it's a long short line, long and short. Also have a center line here. And then there is my square base. That will give me my square base. Here is my ground line. Alright. There is my ground line. There is my front view base. And then I will complete the square here. Oh, it's not at the center. My circle is off center. It's 20 millimeters away. I'm sorry, it's 20 millimeters away. In this case, my center will not work. This is the one for the circle. The one that you want is the one for the circle. It is 20 millimeters away. And then the second, diameter 40, which is radius 20. Diameter 40, radius 20. That is my radius. It will be the radius 20. There we are. There we have it. And then we can project here tangential to the circle so that we establish the top part of the front view. And then they say the height is 50. The height is 50. Let's get the height there. The height is 50. This should be our height. 50. We have this as our seam. It has been cut right here, split open from the center. We have that as our seam. that as AB, which is here. Our same is here. A B, and then let's name our rectangular base. A B, so we see here D, E, and F, which means here we are looking at C. Behind C there is D. We are looking at F at the bottom. Behind the F, we'll be looking at E. On top, it's a circle. It's around here. It's a circle. So when we have a circle, we divide it into 12 equal parts. Let's divide our circle. We use a 30 degrees at square to do that. Remember, they say we're going to cut it here. We'll start here at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0, and 12. There we are. It is also necessary that now let us make some fold lines. These are fold lines. We're going to fold it from these corners. 1, the fold lines, they help us in making those triangles that we use for developing our surfaces. It helps us to make those triangles that enable us to develop our surfaces for our surface development. You will see as you go along. This is where we are. Here at the top we have 9, and then there we have 3. Below where you have others 2 and 4, you will locate 2 and 4 here, and then you locate 5 and 1 here. It's 2 and 4, 5 and 1. And then here you will have 0. Behind 0, 0 and 12 on the same point. Then behind that you will have 6. I'm going through with you very slowly. Here you have 11 and 7. You will have 11 and 7, 10 and 8. 11 and 7, 10 and 8. Then on the other side you have 9. Alright, we are going to split it open from here. So AB is not parallel to the ground line. AB is not parallel to the ground line. So we rotate 1. We make 1 to be parallel to the ground line. I will rotate A. When A is rotated, A now is here. It's parallel to the ground line. So I project. A has moved now. A is here. A is here. that will be the true length. You see that true length? I may as well draw it here just to show it to you. That true length is for AB. Is for AB. I've rotated A to be parallel to the ground line and projected it. A moved from here to there. There is its true length. So I prefer to develop all at once, doing that simultaneously. So on the inside I have A. Right from the outside, they will move on the outside. Inside here I will have A to B. The true length of A to B is that one. That is the true length from A to B. A to B is the true length here. A to B. That will be my true length. I've started now with my surface development. I'm developing this surface area now. This is my A to B. Now from here, from B, on the outside I move to C. On the outside I move to C. BC. Look at BC. Here is B. B is at the bottom. BC. Parallel to the ground line. That is the true length. BC is the true length. BC is the true length. Here it is. BC is the true length. From B to C is the true length. Like I've shown in the previous video, we are using triangles A, B, C. So now BA, we found the true length. There it is. AB, we don't know the true length. But what we know is that this true length will be the same as this true length. Let's get this true length that I've marked 0. That true length there, I rotate C, making it parallel to the ground line. Now it's parallel to the ground line. See, it is now parallel to the ground line. Now I project that C. That C will be located here now. That true length from A to C. Where is A? A to C. From A to C to be that one. This one that I've marked 0. You can as well put your true length on one place, because this is the true length for there to place it nicely here. Now A to C. Now I can move from A to C. There is the true length A to C. So there is C. With this fold line that I've created, AC. Here is the fold line that I've created, AC, but from B to C. I join from B to C. Now I'm moving from A. From A I must go to 1. But now I've got a challenge. This thing is round. So I must straighten up. I must open it. It's a circle. It's a circumference. So I opened it. It's a circle. We make it a circumference. Circumference, if you want to find circumference, open the circle. It is, circumference is equal to pi times diameter, which is pi times, what's the diameter there? It said it was 40. That gives us, let's check with mathematics, this is ayazi, pi times 40 give us 125.66, 125.66. Now these divisions, they are 12. So this 1,66, we must divide it by 12, so that we get, divide by 12, we get 10,47. 10,47. So the distance from here to there, when you have straightened it up, say straight, when it is straight, it is 10,7. So you will have this triangle A1C. A1 is somewhere there and C, A1C. So, but now we have established that each distance, let's start from A to 1, it is 10,47. 10,47 on your ruler there is 10,47. It's 10 and a half, almost 10 and a half. No, you don't go to 11, it's almost 10 and a half. If you can see clearly there, it's 10 and a half. There is 10 and a half, it's there, 10 and a half. Now I must now move from C to 1. From C to 1, we have a challenge. Now from C to 1, the true length of this line, we don't know it. We don't know it. So let's give it Roman figure 1. But once we find it, it will be the same as this one. What do we do? I can take it from this side also, because it's whether I take it from this side. Okay. Let me not confuse you. Let me take it from this side. Let me rotate 1. When I rotate 1, there I'm transferring my 1. 1 will be here on that side. Oh, what's wrong? Yeah, 1 will be, I'm trying there. There is my 1. There is my 1. Not this one. I've rotated 1. 1 now is going to be parallel to this ground line. 1 now has been moved here. So I'm going to locate 1. Where is 1 on the other side? Looking for 1. Where was 1? 1 is Yambelana no 5 from here. It's now there. So it is there. I did not move C. I did not move C. I've only moved 1. There it is. This one is this true length. Now I take that true length. Take that true length. That true length from C. It will lead me to 1. Here is my 1. My 1 is here. There is my 1. In this case, because this is the line that I've considered, I don't join here because it's a curve. So I would like to join my curve very smoothly, because this one was a second. Now from 1, I move to 2, and from C I move to 2. From C I move to 2. Now C to 2, this true length, I'll do this. It will be the same as that true length. From C to 2. Let's check this one, C to 2. This one, when I rotate it, it's there. And then I transfer it. It will be from C to 2. It will be this true length. Now from C to 2, there is its true length. Then I transfer it from C, 2 will be somewhere here. Now I must move from 1 to 2. From 1 to 2 is the same distance, which is 10, 10,5, 4, 7, 10 and a half. Here is my 10 and a half here. Now from 2, I will get 3 here. From 1, I will get 2 here. There is my 2. And then from 2, I will get 3 here. I don't want to twist my compass every now and then. Now 3, now C to 3. It's a different one, but it's the same as that one. C to 3. Let's check if I can put it this side. C to 3. I don't like going outside my margin here. I don't like, but I know this is the same as that. I can also, it will give me another trouble, but I can as well move inside. I can move here, I can take C anywhere where you are comfortable. I put it here. Now my C is here, my C is here, it will be here. Not my C, by the way, my 3 has moved from here to there, and the true length thereof is this one. 1, 2, 3. I've marked my true length. They won't confuse me. When I'm referring to this line, I look for a line that has this Roman figure 3. From C, that will give you my true length, and then true length of this to 3. There it is, the true length from there to 3. So my 3 is here, my 3, and then there are these fold lines. Might as well just put my fold lines. Yeah, so now we've done 1, 2, 3, 1, 0, 1, 2, 3. Now we're moving from 3 to D. Here is a triangle. All these were triangles. All of them were triangles. We're using that method we talked about in an earlier video of triangulation. Now we are now moving from 3 to D, but you must first move from C to D, this triangle. So from C to D, C and D is a point view, which means on the other side you are seeing a true length. The point view is like this. If this is AB, you are looking at it from this side. AB, you are seeing it, B is behind A. You are looking at a point view, but me now on this other side I'm seeing the true length. So there is the true length of C and D, of CD. That will be the true length of CD. The true length of C and D. Now I must locate D. I must now locate D. D will be somewhere here. And then I will move now from 3 to D. From 3 to D. From 3 to D is this one. So this one, maybe I can say it is this. This one will be the same as that one I represent by X. This one will be the same as that one. Now, I may as well, there are so many lines on the left hand side. I don't want to do it with this line. I will do with that one. They represent the same length. I will rotate E. I will rotate E to the side. E will be there. And then I'll transfer that. E will be here. I'll transfer that to there. Now E is no longer here, it's there. From 9, now here is 9, E. That will be the true length of this line segment. True length of that line segment. So that line segment, its true length, now it is from E, is 3 to D. 3 to D. Now I'm moving from 3 to D. D will be here. I've located my D is here on the outside because it's not curved. I may as well join. It was a fold line from 3 to D. It was a fold line from 3 to D. Now I must now move from D to 4. From D to 4. I will call it Y. This one I'll call it Y. D to 4. D to 4. I'll find its true length there. From the right hand side. I'm not taking from that side. Saying I'm a true length, there are so many true lengths here. I'm trying the other side because it may also be represented by this one on this side. Now, parallel line. E has been moved to here now. There is my E. It's here. But 8 has not been moved. Here is 8. It has not been moved. 8 has not been moved. That true length is the one I call Y. So Y also represents that one. Here is my Y, which is now from D to 4. D to 4. Y, D to 4. D to 4. From D, 4 will be somewhere here. Now I move from 3 to 4. 3 to 4 we know is the same as that one, which is 10 and a half. 10 and a half, 10.47, which is 10.5. My 4 will be here. Whilst my compass is still at 10 and a half, I locate 5 somewhere there. I locate 4, I've located 4, 5 will be somewhere here. Now I must connect D to 5 and 4. Already I've connected D to 4. I've already connected D to 4. Now I must connect D to 5 within my fold line. D to 5 XY, I will call that Z. Is Z. D to 5 is Z. Now, is Z. Where must I get my Z? Maybe I will rotate E on this side. Still on this side, making it parallel to the ground line. It's almost on the same line. It's almost. Even if you take it, you rotate 7. Here, put 7 parallel to the ground line. 7 is there. Slightly. You see, it's also at 7. Almost at 7. Just slightly above 7. I've rotated 7, not E. E is there. I have only rotated 7. I've rotated 7. This is my Z. So for my Z, 5D is represented by Z. 5D is represented by Z. 5D. It's just a little bit confusing when you're starting, but as you go on, then you'll be fine. You will be fine. 5. And then I locate C. I locate now here is my 5. Okay, let me draw also the fold line there. And then from D, I go to 6. From D, I go to 6. Look, D to 6. It is at an angle. It's like this. But you look at it, it's like it's flat. No, it's also like this. It is from D to 6. 6 is here. D to 6. This is parallel to the ground line. On the other hand, we are seeing the true length, this line from C to D. So from C to 6, it is the true length. Since it is parallel, D to 6 is parallel to the ground line. D to 6 is the true length. So D to 6, I have not drawn that line. I'm just taking it. D to 6, it's not there. Don't confuse it with this other one. No, it's another one here. D to 6, it's the true length. Now, D to 6 is located somewhere here. And then from 5 to 6, it's 10,47. Here is my 10,47. From 5 to 6. Okay, from 6 to 7. Now I already have 6. And then 7. I will not use D now to go to 7. Now from 7, I must use E. So let me move now from D to E. I'm moving from D to E. D and E, parallel to the ground line. That is the true length. From D to E. D to E is the true length. That's the true length. D to E. It is the true length. D to E. I'm trying to locate E. I cannot find E. But E, I can get it from 6 to E. Now, here is another triangle. It's D, D6E. D, D6E. D6E. Now, I must move now from 6 to E, parallel to the ground line. Here is my 6 to E. That is the true length. 6 to E. 6 to E. 6 to E. 6 to E. 6 to E is the true length. Now I join. Here is my E. 6 to E, fold line, and D. 6 and D also connect. 6 and D also connect. There's a fold line. Now I must move now from E to 7. E to 7. Z. I must Z. E to 7. Z. Here is my Z. E to 7 is my Z. There is my 7. May as well put your full line that was already there. Then now E to 8. E to 8 is my Y. E to 8 is my Y. Here is my Y. E, I will find 8 somewhere here. E to 8. And then 8, 7 to 8 is 10,47. 10,47. 10,47. Let me check, is it right? Yes. 10,47. There's my 8. I might as well speak in my 9. There, here is my 8. My 9 from E to 9. E to 9, X. E to 9, it's X. E to 9, X. E to 9, X. Here is my 9. There was a fold line here and there. E to 9. And then look, E to 9. Now I must move now from 9 to F. 9 to F is this one. But at least I know E to F. E to F, I'm using this triangle now. E to F E to F, point view, true length. Point view, true length. This is the true length for E to F. F is somewhere there. Now I must move from 9 to F, is this one with Roman figure 3. This one with Roman figure 3. Now that is from 9 to F. 9 to F. F will be here. My F here. And then it was triangulated by 9. It was formed by this triangle. Now I will move from now F to B. F to B parallel to the ground line, that is the true length. F to B. F to B. That's where I started. I'm about to finish. F to B. F to B. We'll find it somewhere here. F to B. Now I must move from 9 to 10 now. From 9 to 10. Now even if I take it here, I don't have always to take it there. I don't have to take it there. Those distances are the same if you remember. 9 to 10. So I must move from F to 10. From F to 10 is this one with Roman figure 2. And here is the one with Roman figure 2. It is this one. Roman figure 2, it is from, is from F to 9. Now from F to 10. From F to 10, Roman figure 2. F to 10 is Roman figure 2. Here is my 10. Here is my 10. And then from F to 11, Roman figure 1. F to 11, it's Roman figure 1. This one, filling up. Roman figure 2, we're referring to that one. Now we're referring to the other one, Roman figure 1, which is F to 11. F to 11, 11 will be somewhere here. Now I must move now from 10 to 11. From 10 to 11. From 10 to 11. So this distance, they are all equidistant. Then 10 to 11. My 11 is here. From 11, I might as well locate my 12. 12 will be somewhere here. There is 11, 12 will be here. So now there is 10 to 11. 10, yeah. There is F to 10 and F to 11. Now I'm looking for F to 12. F to 12 is the one that marked 0. F to 12 is this one here. F to 12 is this one here. I'm saying now from F to 12, yes. F to 12. My 12 is here. Now I will move from 12 to B. From 12 and A, A to B. 12 so A. 12 to B. I want to locate B. Liana besesi makile for B. This one was already ready for B. Now from 12 to B. 12 to B, A to B is that one. AB, it's written AB here. There we go. It's there. Now I can join. F to 12. F to 12 is there. There is F to 12. fold line. Now very nicely you join, you will join. My points, I will start off very faintly. You must have a steady hand, guys. Very faintly. Now when you are sure with your line, you make it solid. But you can draw a better line than mine. There it is, ladies and gentlemen. Draw it as often, not the same one, as many as you can. You will understand it, or you can draw this twice if you don't understand it, or whatever number of times. As long as you understand the true lengths, then I don't think you will struggle that much. It's not one of the easiest. It is not one of the easiest, but I hope you have enjoyed it. But do make sure that your lines are like this, so that you continue. Solid lines are solid lines. There should be consistency in your line. There should be consistency in your line. I hope you'll understand it. I know your classmate or your teacher might help you when you don't understand clearly. Thank you, guys. It must take, you need to take about 20-30 minutes doing that. We have taken 42 minutes. We took 42 minutes in doing this. Thank you.